This is section 9.3, double angle, half angle, and reduction formulas. So here what we will be looking at is looking at trig functions that kind of look like this. So now we've kind of looked at the sum and difference of formulas where you're adding two different angles. Now what we're going to look at is multiplying an angle by a number, dividing an angle by a number, or in particular by 2. And then what happens if I have the whole trig function raised to some power. So this is really, really useful. So right now it might seem like kind of like weird why we're doing this, but it comes up a lot in calculus, especially if you're going to take Calc 2. So it appears a lot in Calc 2, so you need to be able to kind of reduce a lot of these formulas a lot easier to make it a lot, I don't know, simpler to work with. So being able to use these formulas up your sleeve will be really, really good, or else you will be struggling a lot. So here, basically, you have the double angle formulas. So the sine of 2 theta is just equal to 2 sine theta cosine theta. The cosine of 2 theta, you actually have 3 different types. Cosine squared theta minus sine squared theta, not to be confused with cosine squared theta plus sine squared theta. Here there's a minus. So when it's minus, that's just equal to cosine 2 theta. It's also equal to 1 minus 2 sine squared theta and 2 cosine squared theta minus 1. And the way that you kind of just find out these 3, I'll show you in a little bit, is basically based on the first one. And then you have the formula for tangent to theta, which is just 2 tangent theta over 1 minus tangent squared theta. To derive the formulas is not that difficult. All you got to do is just write sine 2 theta as sine of theta plus theta, because we know that these two guys is going to give me 2 theta. But if I decompose it like that, then I can just use the sum and difference formula by letting that be theta. And you'll see that you can get really easily the 2 sine theta cosine theta. So here, same thing, using the Pythagorean identities, you can easily, not the Pythagorean, the sum and difference formulas, you can easily get this guy. If I use the Pythagorean identity, cosine squared theta equals 1 minus sine squared theta, and I plug this guy in here, notice that I get this equation. If I plug in sine squared theta equals 1 minus cosine squared theta into here, you'll see that I get the third equation. So just something to keep in mind of, okay? And then double angle for tangent is just basically just taking this guy, okay, and rewriting it by the other guy. Okay, so it's not, these formulas are just basically based on the previous ones. I won't derive them here, but if you want to go ahead and derive them, you can for fun if you want to. All right, so what we really want to do is we're gonna use these formulas to do a couple of problems. So what will I ask you on an exam or on homework? So here, let's start off with this problem. Whoops, what did I do? Okay, so suppose that sine theta is less than 0 and cosine theta equals 1/4. So find cosine 2 theta, and in what quadrant is the angle 2 theta? Okay, so we have a couple of things. So the first thing that I tell you is that the sine theta is less than 0 and that cosine theta equals 1/4. So just like the sum and difference formulas, we want to know where exactly this theta is. So what quadrant is this theta? So this says that sine is negative. That's basically what that's saying. Here, the cosine, if you look at the cosine, it's positive. So we got to think about, in our quadrant, all students take calculus, where is the sine negative and the cosine positive? Okay, so that without much to know is going to be quadrant 4. Okay, because here sine is negative and the cosine is going to be positive. So in quadrant 4, basically you're going to have your triangle looking like this, and here's going to be theta. So now let's go ahead and try to fill out this triangle. So we know that cosine of theta is going to be 1 over 4. That's going to be the adjacent, which is going to be this guy, which is going to be 1 over the hypotenuse, which is this guy. That's going to be 4. And now we just need to figure out the other guy. It's going to be 1 squared plus b squared equals 4 squared. So this is going to give me 1 plus b squared equals 16. So b squared equals 15. So b is going to be equal to plus or minus square root of 15. Now notice I'm writing plus or minus now because we don't know if it's going to be positive or negative. Because we're in quadrant 4, we know that this guy down here is going to be negative. So we're going to choose the b that's going to be negative in this case. All right, cool. And now, so that's what we have. Now let's figure out what cosine 2 theta is going to be. Okay, so and now at this point, you can use whichever formula you want. I'm going to just use formula number 1. Doesn't really matter for no specific reason. You could have chosen the other ones. So that one's just going to be equal to cosine squared theta minus sine squared theta. So now, remember that the squares is basically, we can always rewrite them like this if you want to. Because they're both being squared. So here, cosine, we already know what cosine is, just as 1/4. It's going to be 1/4 squared minus sine of theta. Sine of theta is going to be the opposite over the hypotenuse. That's going to be negative 15 over 4 whole quantity squared. So the first one's going to be 1 over 16 minus the next one's going to be 15 over 16. Okay, which in this case is going to give me negative 14 over 16. So that's going to be my answer. All right, so now what this is saying is where exactly, in what quadrant is the angle 2 theta? Okay, so let's think about right now where theta is at currently. So currently, if you look at this guy is at 3 pi over 2 and then 2 pi. Okay, which is basically, if you kind of want to think about it, is basically 270 degrees and 2 pi and 360 degrees. So basically theta, you can do it in radians or degrees, whichever you want. Theta right now, currently, is between 270 degrees and 360 degrees. Okay, in degrees. You can also do it in radians. Now we don't want theta, we want 2 theta. So what I'm going to do is I'm going to plug in 2 theta in there. Okay, so I'm going to plug in 2 theta. Okay, so, but the thing is, like when I plug in a 2, I'm going to multiply this guy also by 2. I'm going to multiply this guy also by 2. Okay, so what is this going to be? So 2 theta. Okay, so I'm going to take 270 times 2. That's going to give me 540. And then 360 times 2 is going to be 720. Okay, so 2 theta is between 540 and 720. So where exactly is that at? Well, one way that you can do it is that to think about where exactly 540 is by using coterminal angles. So if you subtract 540 from 360, you're going to get 180. Okay, and if you take 720 and you subtract it to 360, you're going to get 360. So basically what that tells me is that this angle 2 theta is going to be somewhere between 180 degrees and 360 degrees. Okay, so somewhere in here. Now, what exactly is that angle? Well, that angle will involve us actually solving this trig equation. So cosine of 2 theta equals negative 14 over 16, which at this point you can probably try to do, but it's going to be a little tricky for you to do this problem because if you try to do cosine inverse, you're going to get something in the wrong quadrant. So we're not going to do it just yet. I just kind of want you to kind of see where exactly we're going at. Right now we know that this 2 theta is going to be somewhere in quadrant 3 or in quadrant 4. We don't know exactly where it's at, but we can know that that you can try to figure it out somehow. For right now, we won't. This is all I really wanted you to kind of do. It's going to be somewhere in quadrant 3 and somewhere in quadrant 4. When we get to trig equations, you'll be able to figure out where exactly this 2 theta is going to be. And I think it is going to be in quadrant 4 again. Okay. So I'll show you how to do that when we get to trig equations. So let's do this other problem. So given that sine of phi, so if you remember, we've been using theta, alpha, and beta a lot, and even gamma. So this funky looking sign, which kind of looks like a 0 and then a line through it, remember that this is just phi or phi. I don't know how you want to call it. So here we want to know that sine of phi is equal to 5/8, and phi in this case is between 0 and pi/2. So we want to find sine 2 theta. I'm sorry, sine 2 phi, cosine 2 phi, and tangent 2 phi. So the first thing to kind of note is that a phi in this case is going to be between 0 and pi/2. That's in quadrant 1. Okay, so that's going to be here. So phi is right here. And sine is going to be the opposite over the hypotenuse. Let's figure out what a is. So a squared plus 5 squared equals 8 squared. So a squared plus 25 equals 64. I'm going to subtract the 25 over. So I'm going to get a squared is equal to, what is that? So 64 minus 25, that gives me 39. I'm going to take the square root. And notice that this guy is going to be positive because we're in the first quadrant. So this is going to be the positive square root of 39. Okay. All right, and now we can just figure out the rest of them. So sine of 2 phi. Okay, so remember that that's just going to be equal to 2 sine phi cosine phi using the double angle formulas. So you're going to have 2 sine of phi is going to be just 5/8 times cosine phi. It's going to be square root of 39/8. Okay, so the top part is going to give me 10 square root of 39 divided by 64. Okay, and then if you want to go ahead and just reduce it a little bit, 10/64, that's just going to give me 5/32. So 5 square root of 39/32. So that will be my solution. So these problems, I usually typically want the exact answers. Then we have the cosine of phi, 2 phi. Okay, that one is just equal to cosine squared phi minus sine squared phi. So we know that the cosine is going to be equal to the square root of 39/8 squared minus the sine squared phi. That's just going to be equal to 5/8 squared. So the top part is going to be 39/64 minus 25/64. So I'm going to take this 39, subtract by 25. That's going to give me 14/64. And then I can always just reduce this guy to 7/32. And then my last one will be tangent of 2 phi. Okay, this one we can go back. Okay, so 2 tangent theta, 1 minus tangent squared theta. 2 tangent theta over 1 minus tangent squared phi. Okay, did I get that right? I always forget this one. Yeah, okay. Alrighty, so this is going to be the double angle identity for this guy. So you're going to have a 2 tangent phi. Okay, so tangent phi is going to be opposite over adjacent divided by 1 minus tangent phi, which is going to be 5 over square root of 39. And then we're going to square this. So you're going to get 10 over square root of 39 divided by 1 minus 25/39. So the bottom part is just going to be 1 minus 25/39. That's going to give me 14/39. Okay, and then I'm just going to multiply these guys out, or divide these guys out. So square root of 39 divided by 14/39. Okay, and that's going to give me 5 square root of 39/7. Okay, so this is just mainly using the calculator. So being able to use the identities and plugging it into the calculator and then using a little bit of geometry is basically all you really need for these problems.